The demand for security professionals has never been higher. Organizations across the world require professionals with your knowledge and skills to protect their systems from attackers. And with the number of threats on the rise, security professionals often perform a diverse set of tasks. It's for this reason that we'll incorporate another tool as part of our security toolbox. A tool that can simplify many common security tasks. A tool that's used not only by security professionals, but also by engineers and data scientists. That tool is Python. Hi there. Congratulations on getting to the next step in your security journey. My name is Angel, and I am a security engineer at Google. I'm excited to be joining you in this course. If you've been following along sequentially, you've already applied the specific tools that security professionals use during the detection, analysis, and response processes. And you also learn how to communicate with your computer through Linux and SQL. Now, we'll focus on how programming in Python can be used for some common security tasks. As you consider your next career step, you might find that Python skills will help you in your everyday work. This course is designed for learning Python, starting with the basics. Then, you'll gradually build on those basics and apply what you learned to gain hands-on practice with security-related examples. Fortunately, Python is known for its readability, and just like all languages, it will get easier with practice. Pretty soon, you might be using Python in your security career. Python can automate the manual effort of important tasks, like file parsing. Python has helped me a lot in my career here at Google. I am part of a team responsible for protecting Google's infrastructure, which includes everything that employees use, from laptops and desktops to the network and cloud resources. We do this by engineering security solutions and automating the repeatable parts of our work. What I like about Python is that it has cross-platform support, and a lot of tools have already been developed by members of the security community that use Python. This makes it easy for me to find the tools I need and get support with blockers so I can complete both my professional and personal projects. My hope is that this course will be helpful to you. Let's explore what we'll cover. First, you'll be introduced to basic programming concepts in Python. You'll learn why Python has been adopted by security professionals around the world. You will also develop and run your first program. After this, we'll focus on writing effective Python code. We'll discuss concepts that help make our work more efficient. Our next main topic is on working with strings and lists. These will be relevant to a lot of the data that you'll encounter in a security context. And finally, you'll wrap up the course with an exploration of putting Python into practice. You'll learn about opening and parsing files and about debugging code. Python is certainly a useful skill for security analysts. Let's get started. The process of learning a new programming language is similar to learning a new language. For instance, like any human language, programming consists of words organized together to form lines of code. Lines of code are used to communicate with a computer, similar to a sentence, telling it how to perform a task. In this section, we're going to start learning the language needed to communicate with a computer as we explore some key components of Python. We'll start by introducing the basics of programming, starting with why security analysts use Python. Next, we'll start building the foundations for Python. We'll discuss data types. Then, we'll cover variables. Lastly, we're going to learn about specific statements we can make in Python, like conditional statements. Conditional statements help us incorporate logic into our programs. The second type of statement we'll learn about is the iterative statement. Iterative statements allow us to repeat a line of code multiple times without having to rewrite it. Learning Python helped me succeed in my career because using Python allows me to free up time from repetitive tasks and instead focus on more challenging tasks and problems. Successfully applying automation reduces my overall workload, increases productivity, and reduces the risk of human error. The use of automation also allows me to focus on my engineering tasks, which require more creativity, collaboration, and problem solving. Are you ready to start programming in Python? Let's begin. Security professionals use a variety of tools. One of those tools is computer programming. Programming is used to create a specific set of instructions for a computer to execute tasks. Let's take an example of a vending machine. Think of a vending machine as a computer that supplies food or drinks to customers. To receive an item, the customer inserts the money into the machine and then selects the item they want. Let's say the customer provides the machine with a value of $5. The machine stores this value while you make your selection. If you select a candy bar that costs $2, the machine takes this input, otherwise known as an instruction, and then understands to output your candy bar for $2 and provides the change back of $3. There are many programming languages in existence. Here, we'll focus on Python. Python is considered to be a general-purpose language. This means that it can create a variety of different programs, and it isn't specialized in any particular problem. In fields such as web development and artificial intelligence, Python is typically used to build websites and perform data analysis. In security, the main reason we use Python is to automate our tasks. Automation is the use of technology to reduce human and manual effort to perform common and repetitive tasks. Python is generally best for automating short, simple tasks. For example, a security analyst who's dealing with a security incident might have a log with necessary information. Reading through these manually would take too much time, but Python can help sort through this, so the analyst can find what they need. As another example, an analyst might use Python to manage an access control list, the list that controls who can access the system and its resources. It would be potentially less consistent if the analyst had to manually remove an employee's access every time they left the company. However, a Python program can periodically monitor this instead. Or Python could also perform some automated tasks like analyzing network traffic. Though these tasks can be done through outside applications, they are also possible through Python. In addition to automating individual tasks, Python can combine separate tasks into one workstream. For example, imagine a playbook indicates that an analyst needs to resolve a certain situation by deleting a file and then notifying the proper individuals. Python can connect these processes together. So, why exactly might a security professional choose Python for these tasks? There are several advantages Python has as a programming language. For one, Python is user-friendly. Because it resembles human language, it requires less code and is easy to read. Python programmers also have the benefit of following standard guidelines to ensure consistency with the design and readability of code. Another great reason for learning Python is that there's a large amount of online support. Python also has an extensive collection of built-in code that we can import and use to perform many different tasks. These are just some of the reasons why Python continues to be in high demand across different industries throughout the world. You'll most likely use it in your security career. Wow, all of this sounds great. So let's take a short break, and next, we'll finally get to run some Python code. I'll meet you in the next video. Hi there. Previously, we discussed the basics of Python. Now, we'll practice writing and running code. When we work in Python, we refer to what we write as a script or a program. There are subtle differences between the two. Let's compare a computer program to a theater performance. Almost every theater performance includes a written script. Actors study and memorize a script to say it out loud to an audience. However, that's not the only component. There's also the whole performance. Directors make decisions on what kind of lighting to use, or costumes, or what the stage looks like. The performance, as a whole, involves a lot of design choices, like set design, lighting, and costumes. The process of creating this production is similar to the process of programming in Python. Programming involves a lot of design decisions, but the process of scripting in Python is more like writing the specific words that the actors will say. In Python, it's good practice to start with a comment. A comment is a note programmers make about the intention behind their code. Let's add one now. We start with the hash symbol to indicate that this is a comment, and then we'll add details about our intention. Here, we're going to print "Hello Python" to the screen. Okay, now let's write our first line of Python code. This code uses print. Print outputs a specified object to the screen. After print, we put what we want to output in parentheses. In this case, we want to output the string "Hello Python." We must place string data in quotation marks. These quotation marks are just one example of syntax that you will encounter in Python. Syntax refers to the rules that determine what is correctly structured in a computing language. And now, we'll run this code so the computer can output the string. You just ran your first line of code. Since our syntax is correct, the string is now displayed. Now that you've experienced writing and running code in Python, we are ready to discuss its basic components. Meet you soon. Our next topic relates to categorizing data in Python. First, let's take a moment to consider another environment where we apply categories. We'll think about working in a kitchen. When cooking, we can categorize the ingredients we use. For example, carrots and peppers are vegetables, and chicken and beef are meat. These categories are important because they affect how we handle these ingredients. When working in Python, data types achieve a similar purpose. A data type is a category for a particular type of data item. Python uses several data types. We'll focus on string, float, integer, boolean, and list data. When we printed the text "Hello Python" in our previous video, this was an example of a string. A string data is data consisting of an ordered sequence of characters. These characters could be letters, symbols, spaces, and even numbers. Numbers in the string data type cannot be used for calculations. All characters in a string must be placed inside quotation marks. Locally, Python will tell you by giving you an error message if you forget a quotation mark. Let's use our code from before and explore what happens when we leave off the quotation mark. Notice how one of our quotation marks is missing at the end of the string. And when we run this code, we'll receive an error message. Python also supports numeric data types as well. When working with numeric data, we don't put quotation marks around the data. Numeric data includes floats and integers. Float data is data consisting of a number with a decimal point. This includes fractions like 2.1 or 10.5. It also includes whole numbers with a decimal point like 2.0 or 10.0. Integer data is data consisting of a number that does not include a decimal point. Numbers such as 0, -9, and 5,000 are valid integers. So far, we've used the print function to output a string. But it can also be used with float and integer types for calculations. Let's try out an example of this. First, since it's good practice, Let's add a comment to explain the purpose of our code. Then, we'll tell Python what to calculate. The output gives us the answer. 1 plus 1 is 2. We can use print with float and integer data to perform all kinds of mathematical operations like addition, subtraction, multiplication, and division. The third data type in Python is called a Boolean. Boolean data is data that can only be one of two values, either true or false. Booleans are useful for logic in our programs. For example, let's compare numbers and determine the Boolean values of these comparisons. First, we'll use the print function to evaluate if 10 is less than 5. Then, we'll also evaluate if 9 is less than 12. So, what do you think? 10 is not less than 5, but 9 is less than 12, right? Let's see how Python handles this when we run it. Python agrees. The first line of output tells us that it's false to say 10 is less than 5. And the second tells us it's true to say 9 is less than 12. We'll use Booleans more when we start including conditions in our code. And the last data type we'll cover is lists. List data is a data structure that consists of a collection of data in sequential form. We'll create and print a list that prints all the usernames of the 3 individuals that have access to a confidential file. First, we'll add our comment about an intention to print this list. After the keyword print, we'll add our list. We need to place the list in brackets. After this, we place the individual items in the list in quotation marks and separate them with commas. Okay, now let's run this. As expected, we get the list. When it prints, it still has the brackets. This is just the beginning of what you can do with lists. As you grow with your Python skills, you'll learn about how you can access and edit individual items in the list. So that was a brief summary of 5 major data types in Python: string, integer, float, Boolean, and list. These data types are some of the more common ones you'll work with as we progress through our lessons. Previously, we compared data types to the categories we have for different ingredients we use when cooking, like vegetables or meat. Some of these categories we use for data types are string, float, integer, Boolean, and list. Now, let's make another comparison. When working in the kitchen, we also use storage containers. These containers can hold a lot of different things. After one meal, a container might hold rice, and after another, it could hold something different like pasta. In a similar way, in Python, we have variables. A variable is a container that stores data. To create a variable, you need a name for it. Then, you add an equal sign, and then an object to store in it. Creating a variable is often called assignment. The best practice for naming variables is to make the names relevant to what they're being used for. Let's use a variable to store a device ID. We'll name our variable device ID. Add the equal sign, and then assign it a value of H32RB17. Because the data type for this variable is a string, we'll place that value in quotation marks. Let's run the code. Our variable is now saved into Python. The purpose of creating variables is to use them later in the code. Using variables can also be referred to as calling them. To call a variable, you type its name. This tells Python to use the object that the variable contains. Let's add to the code we've just written and call a variable. Let's just have it print the variable. To do this, we use the print function and ask it to print the value stored in the device ID variable. When using a variable in our print function, we don't use quotation marks. This time when we run it, something happens. Python prints H32RB17 to the screen. Let's add one more line of code to demonstrate the difference between printing a variable and printing a string. We'll ask Python to print a string that contains another device ID, M50PI31. Because this is a string data and not a variable, we place it in quotation marks. Now, let's run the code and see the results. It executes both print statements. The first reads the variable and prints the value it contains, H32RB17. And the second reads the specified string and prints M50PI31. But if we could use the string directly, why do we need variables? Well, we often use variables to simplify our code, or make it cleaner and easier to read. Or if we needed a very long string or number, storing it in a variable would let us use it throughout our code without typing it all out. In the previous example, the variable stored string data, but variables can store a variety of data types. Variables have the data type of the object currently stored in them. If you're unsure about the data type stored inside of a variable, you can use the type function. The type function is a function that returns the data type of its input. Let's use the type function in Python. We'll start by creating our variable. Then, we'll add a line of code that includes the type function. This line asks Python to tell us the data type of the device ID variable, and to assign this to a new variable called dataType. After this, we can print the dataType variable to the screen. Perfect. Python tells us that the value that device ID contains is a string. When working with variables, it's important to keep track of their data types. If you don't, you could get a type error. A type error is an error that results from using the wrong data type. For example, if you try to add a number and a string, you will get a type error because Python cannot combine those two data types together. It can only add two strings or two numbers. Let's demonstrate a type error. First, we'll reuse our device ID variable that stores a string value. Then, we'll define another variable called number and assign an integer value to it. Let's add a print statement that outputs the sum of these variables. And then we'll run this. We ended up with an error because we cannot add a string to a number. Let's cover one more topic related to variables. Earlier, we mentioned how variables are like containers. What they hold can change. After we define a variable, we can always change the object inside of it. This is called reassignment. Reassigning a variable is very similar to assigning it in the first place. Let's try this out and reassign a variable. We'll start by assigning the same string of H32RB17 to our variable device ID. We'll also include a line of code to print this variable. Now, let's try reassigning the variable. We type this variable's name, add an equal sign, and then add the new object. In this case, we'll use the string N73AB07 as the new device ID. We'll also ask Python to print the variable again. Let's see what happens when we run this. Python prints two lines of output. The first print statement came before reassignment, so it first prints the string of H32RB17, but the second print statement came after it changed. That's why the second output to the screen is the string N73AB07. With this code, we reassign a variable with a string value to another string value, but it's also possible to reassign a variable to a value of another data type. For instance, we can reassign a variable with a string value to an integer value. Variables are an essential part of Python, and as we progress through this course, you'll become more familiar with them. Previously, we discussed how to store different data types in variables. Now, we'll begin to move into the concept of automation, so we can create exciting actions with code. Automation is the use of technology to reduce human and manual effort to perform common and repetitive tasks. It allows computers to do these tasks for us, so that we may get back more time in our lives to do other activities. Conditional statements are important for automation. A conditional statement is a statement that evaluates code to determine if it meets a specified set of conditions. The keyword if is important in conditional statements. If starts a conditional statement. After this keyword, we then specify the condition that must be met and what will happen if it is. We use if statements every day. For example, if it's cold outside, then we'll wear a jacket. Or if it's raining, we'll bring an umbrella. If statements are structured with the condition we want to evaluate and the action that Python will perform if this condition is met. Python always evaluates if the condition is true or false. And if it's true, it performs the specific action. Let's explore an example of this. We'll instruct Python to print an account logged message anytime the failed login attempts are greater than 5. Our keyword if tells Python to start a conditional statement. After this, we indicate the condition we want to check for. In this case, we're checking if the user has more than 5 failed login attempts. Notice how we're using a variable called failed attempts. In our complete code, we will have assigned a value to failed attempts prior to this if statement. After this condition, we always place a colon. This signals that what follows is what we want to happen when the condition is met. In this case, when the user has more than 5 failed login attempts, it prints a message that the account is locked. In Python, this message should always be indented at least one space in order to execute only when the condition is true. It's common to call this first line the header, and to call the actions that happen when the condition is met the body. This condition was based on a variable being greater than a specific number, but we can define our condition using a variety of operators. For example, we can also check if something is less than a specified value, or we can check if it's greater than or equal to, or less than or equal to the value. We can also compare if something is equal to a value. When we do this inside a conditional, we need to use a special syntax. It's not just the equals sign, but a double equals. The double equals sign is an important operator often used in conditional statements. A double equals evaluates whether two objects match. It assigns a Boolean value of true when they match and false when they don't. There's one more operator we should discuss. An exclamation mark followed by an equal sign represents the condition of not equal. This operator for not equal evaluates whether two objects are different. It assigns a Boolean value of true when they don't match and false when they match. Let's more closely investigate an example that uses the double equals sign. We'll focus on an example that prints an updates needed message when a particular operating system is running. Here, we've created a condition that checks if a device's operating system matches a specific string that identifies this operating system. To do this, we'll need to use the double equals sign in our condition. When it matches, our program will print a message that there are updates needed. The operating system variable is on the left of the double equals sign. The string OS2 is on the right. If the condition evaluates to true, it performs the action that is indented in the next line of code. Here, if the operating system is OS2, it will print updates needed. If it's false, the message will not print. Notice how this line is indented? This tells Python that the task depends on the if statement evaluating to true. Now, let's write code that incorporates this conditional and get the results. Before we write the conditional statement, we need to assign a value to our operating system variable. We'll make this value the same as the operating system that we'll check for in the conditional. Next, we'll write the condition for our if statement and use the double equals sign to check if the operating system variable is equivalent to OS2. Now, we'll type the action that will execute if the condition on the previous line evaluates to true. We'll tell Python to print a updates needed message. Since we set our operating system variable to OS2, the print statement will execute. Okay, let's run this. As expected, it printed updates needed because the value assigned to the operating system variable was equal to OS2. Sometimes, we want our conditional statements to execute another set of instructions in the event our first condition isn't true. In our example, not being true means that the device is running an operating system other than OS2. This is when we need to incorporate the else keyword into our conditional statements. Else precedes a code section that only evaluates when all conditions that preceded within the conditional statement evaluate to false. Else statements always follow an if statement and end in a colon. Let's use our previous conditional and add an else statement to it. We've included the same if statement, but this time we set the operating system variable to contain a different operating system, OS3. Because this doesn't match the value in the condition of the if statement, the updates needed message won't print. But we can add an else statement and tell it to do something else instead. We type the else keyword followed by a colon. Then we indent the next line and tell it to print a no updates needed message. When we run this code, it processes the else statement after the if statement. Since our if statement will evaluate to false, it then moves on to the else instruction. Let's try it. As expected, it only prints the message, no updates needed. Great work. Now, we've covered how to use if and how to use else. Using conditional statements allows you to incorporate logic into your code. We just learned about conditional statements and how they can develop to allow computers to make decisions. But sometimes we need our programs to simply count or perform a task over and over again. When it comes to tasks that are tedious, it's normal for humans to lose focus and energy. It's in situations like these where computers can be especially helpful. In this video, we'll examine how computers can perform repetitive tasks using iterative statements. An iterative statement is code that repeatedly executes a set of instructions. Iterative statements are also referred to as loops. Setting up a loop allows us to repeatedly use a line of code without having to type it multiple times. Before discussing the syntax, let's run a loop so you can experience what happens. Notice how this code printed all the numbers in the list with only one print statement. That's a loop. There are two types of loops we'll explore: for loops and while loops. We just ran a for loop, and we'll continue to focus on them in this video. Later, we'll explore while loops. For loops repeat code for a specified sequence. An example of this would be using a for loop to print every item in a list. For loops begin with the keyword for. For signals the beginning of a for loop. Similar to conditional statements, iterative statements consist of two main parts. The parts of a loop are the loop header and the loop body. Let's examine the for loop we just ran and use that to explore these parts. The loop header is the line that contains the for keyword and ends with a colon. It tells Python to start a loop. It consists of the for keyword, a loop variable, and the sequence the loop will iterate through. The loop variable is a variable that is used to control the iterations of a loop. The loop variable comes directly after for. A common name for it is the letter I, but you can give it any other name you want. In for loops, this temporary variable is only used within the loop and not outside of it in the rest of the code. The loop variable is followed by the in operator and the sequence the loop will iterate through. In this example, this sequence is a list containing numbers from 1 through 4. It runs each of these numbers through a specified action. We need to remember to put a colon at the end of the loop header to introduce this code. The loop body refers to the indented lines after the loop header. These represent the actions that are repeated while the loop iterates. In this case, it will print each number in the list, first 1, and then 2, and so on. Another important use of for loops is to repeat a specific process a set number of times. And this is done through combining it with the range function. The range function generates a sequence of numbers. As an example, range from 0 to 10 sets a sequence that goes from 0, 1, 2, all the way up until the number 9. When we use range, we start counting at the number in the first position, in this case, 0. Then, when we reach the number in the second position, it tells us where to stop. That number is excluded, so in this case, where the number is 10, the sequence only goes up until 9. An important detail about the range function is that if we don't provide a start point, it automatically starts from 0. 10 represents the stop point. Since the stop point is excluded, the numbers included in the sequence start at 0 and end at 9. A sequence that starts at 0 and ends at 9 will iterate 10 times. Let's run a for loop that incorporates the range function. We'll use range to ask Python to repeat an action 10 times, and then we'll indicate the action we want to repeat. This action is printing an error message that indicates cannot connect to the destination. Let's run this. Using a for loop with the range function allowed us to repeat the same error message 10 times, instead of typing it over and over again ourselves. In this video, we learn about the syntax and structure of iterative statements, and work with for loops as an example. In the next video, we'll cover another type of iterative statement, the while loop. Previously, we introduced iterative statements in Python and focus on for loops. An iterative statement is code that repeatedly executes a set of instructions. In this video, we'll explore another type of iterative statement, the while loop. When we use for loops, the code repeatedly executed based on a specified sequence. While loops still repeatedly execute, but this repetition is based on a condition. As long as the condition is true, the loop continues to execute. But when it becomes false, the while loop stops. This while loop, for example, sets a condition where the variable time must be less than or equal to 10. This means it will keep running until the variable time is greater than 10. Similar to the for loop, a while loop has a header. It consists of the keyword while, the condition, and a colon. The while loop starts with the keyword while. The keyword while signals the beginning of a while loop, and it's followed by the condition that evaluates to a Boolean value of either true or false. The condition contains the loop variable. This variable is used to control the number of loop iterations. However, there is an important distinction in the variables used in for and while loops. With while loops, the variable isn't created within the loop statement itself. Before writing the while loop, you need to assign the variable. Then, you'll be able to reference it in the loop. When the condition containing the loop variable evaluates to true, the loop iterates. If it does not, then the loop stops. This condition will evaluate to true while the variable time is less than or equal to 10. Finally, the loop header ends with a colon. Just like a for loop, a while loop has an indented body that consists of the actions to take while the loop iterates. The intention of this code is to print the value of a variable that represents the time and increase its value by 2 until it becomes greater than 10. This means the first action in this while loop is to simply print the current value of the time variable. Since while loops do not include a sequence to iterate through, we have to explicitly define how the loop variable changes in the body of the while loop. For example, in this while loop, we increase the loop variable time by 2 every iteration. This is because we only want to print the time every 2 minutes. So this while loop prints out all even numbers less than or equal to 10. Now that we know the basics of while loops, let's explore a practical example. Imagine we have a limitation on how many devices a user can connect to. We can use a while loop to print a message when the user has reached their maximum number of connected devices. Let's create a while loop for this. Before we start our while loop, we need to assign values to 2 variables. First, we'll set the maximum value of connected devices to 5. Then, we'll set our loop variable. We'll use I for this and set it to a value of 1. Unlike with for loops, with while loops, we set this variable outside of the loop. Next, we'll create the header of our while loop. In this case, the condition is that the first variable is less than the second variable. Those variables are the loop variable I and max devices. Since we know the value of max devices is 5, we can understand that this loop will run as long as the current value of I is less than 5. Then we indicate what we want our while loop to do. Because this loop runs as long as the user can still connect to devices, we'll first have it print a user can still connect to additional devices message. After this, with each iteration, we'll increment I by 1. When the loop repeats, it will use the new value of the I variable. Python will exit the loop when I is no longer less than 5. Let's also print a message when this happens. We stop indenting because this next action occurs outside of the loop. Then we'll print user has reached maximum number of connected devices. Okay, we're ready to run this. Because of the loop, the first message prints a total of 4 times. The loop stops when the value of I increments to 5. At this point, it exits the loop and prints the second message. Wow, when you combine this new understanding of for and while loops with what you already know about conditional statements and variables, you have a lot of options in Python. Great work. Well done. You've learned about why security analysts use Python and the basic structure of a program. You even written some lines of Python code. Let's review what you learned so far. You first learned about the basics of programming and why it's a very important tool for security analysts. You also learned some of the basic concepts of how programming languages work. You then learned to recognize data types in Python. We focused on string, integer, float, boolean, and list data. Next, we focused on working with variables. You then learned all about conditional statements and how to check for logical conditions using Python statements. Lastly, we work with iterative statements and discuss the 2 types of loops, for and while loops. You'll use this knowledge as you progress through this course and in your career as a security analyst. In the next section, we'll explore other important components of Python, including functions. Welcome back to our Python journey. In the previous videos, we learned all about the basics of Python. We started at the very beginning by understanding how security analysts use Python. We learned several building blocks of Python. We went into detail learning about data types, variables, and basic statements. Now, we'll add to this and learn more about how to write effective Python scripts. We'll discover ways we can make our efforts more efficient. The upcoming videos are going to start by introducing functions, which are very important in Python. Functions allow us to put together a set of instructions that we can use again and again in our code. Afterwards, we're going to learn about Python modules and libraries, which include collections of functions and data types that we can use with Python. They help us gain access to functions without having to create them ourselves. Lastly, we're going to talk about one of the most important rules of programming, and that is code readability. We'll learn all about ways to make sure everyone can understand and work with your code. I'm excited that you've decided to continue your Python journey with me. So let's start learning more. As the complexity of our programs grow, it's also likely that we'll reuse the same lines of code. Writing this code multiple times would be time-consuming. But luckily, we have a way to manage this. We can use functions. A function is a section of code that can be reused in a program. We already learned one function when we work with print and use it to output specified data to the screen. For example, we printed "Hello Python." There are many other functions. Sometimes we need to automate a task that might otherwise be repetitive if we did it manually. Previously, we compared other key Python components to elements of a kitchen. We compared data types to categories of food. There are differences in how we handle vegetables and meat, and likewise, there are differences in how we handle different data types. We then discussed how variables are like the containers you put food in after a meal. What they hold can change. As far as functions, we can think about them like a dishwasher. If you aren't using a dishwasher, you'll spend a lot of time washing each dish separately. But a dishwasher automates this and lets you wash everything at once. Similarly, functions improve efficiency. They perform repetitive activities within a program and allow it to work effectively. Functions are made to be reused in our programs. They consist of small instructions and can be called upon any number of times and from anywhere in our programs. Another benefit to functions is that if we ever had to make changes to them, we can make those changes directly in the function, and they'll be applied everywhere we use them. This is much better than making the same changes in many different places within a program. The print function is an example of a built-in function. Built-in functions are functions that exist within Python and can be called directly. They are available to us by default. We can also create our own functions. User-defined functions are functions that programmers design for their specific needs. Both types of functions are like mini programs within a larger program. They make working in Python much more effective and efficient. Let's continue learning more about them. Let's start our exploration of user-defined functions by creating and then running a very simple function. The first thing we need to do is define our function. When we define a function, we basically tell Python that it exists. The def keyword is needed for this. Def is placed before a function name to define a function. Let's create a function that greets employees after they log in. First, we'll comment on what we want to do with this code. We want to define a function. Now, we'll go to a new line and use the keyword def to name our function. We'll call it greetEmployee. Let's look at this syntax a little more closely. After our keyword def and the function name, we place parentheses. Later, we'll explore adding information inside the parentheses. But for this simple function, we don't need to add anything. Also, just like we did with conditional and iterative statements, we add a colon at the end of this header. After the colon, we'll indicate what the function will do. In our case, we want the function to output a message once the employee logs in. So let's continue creating our function and tell Python to print this string. This line is indented because it's part of this function. So what happens if we run this code? Does it print our message? Let's try this. It doesn't. That's because you also have to call your function. You may not realize it, but you already have experience calling functions. Print is a built-in function that we've called many times. So to call greetEmployee, we'll do something similar. Let's go with a new line. We'll add another comment because now our purpose is to call our function. And then we'll call the greetEmployee function. We'll run it again. This time, it printed our welcome message. Great work! We've now defined and called a function. This was a simple function. We're going to learn something next that will add to the complexity of the functions you write. Previously, we defined and called our first function. It didn't require any information from outside the function, but other functions might. This means we need to talk about using parameters in functions. In Python, a parameter is an object that is included in a function definition for use in that function. Parameters are accepted into a function through the parentheses after a function name. The function that we created in the last video isn't taking in any parameters. Now, let's revisit another function called range that does use parameters. If you recall, the range function generates a sequence of numbers from a start point to the value before the stop point. Therefore, range does include parameters for the start and stop indices that each accept an integer value. For instance, it could accept integers 3 and 7. This means the sequence it generates will run from 3 to 6. In our previous example, We wrote a function that displayed a welcome message when someone logged in. It would be even more welcoming if we included the employee's name with the message. Let's define a function with a parameter so we can greet employees by name. When we define our function, we'll include the name of the parameter that our function depends on. We place this parameter, the name variable, inside the parentheses. The rest of the syntax stays the same. Now, let's go to the next line and indent so that we can tell Python what we want this function to do. We want it to print a message that welcomes the employee using the name that's passed into the function. Bringing this variable into our print statement requires a few considerations. Like before, we start with the welcome message we want to print. In this case, though, we're not stopping our message after we tell them they're logged in. We want to continue and add the employee's name to the message. That's why we're placing a comma after "you're logged in," and then adding the name variable. Since this is a variable and not a specific string, we don't place it in quotation marks. Now that our function is set up, we're ready to call it with a specific argument that we want to pass in. In Python, an argument is the data brought into a function when it is called. For example, earlier when we passed 3 and 7 into the range function, these were arguments. In our case, let's imagine we want to greet an employee named Charlie Patel. We'll call our greet employee function with this argument. And when we run this, Charlie Patel gets a personalized welcome message. In this example, we only have one parameter in our function, but we can have more. Let's explore an example of this. Maybe instead of a single name parameter, we have a parameter for first name and second parameter for last name. If so, we would need to adjust the code like this. First, when we define the function, we include both parameters and separate them with a comma. Then, when we call it, we also include two arguments. This time, we're greeting someone with the first name of Chiara and with the last name of Carter. These are also separated by a comma. Let's run this and welcome Chiara Carter. As we just explored, using more than one parameter just requires a few adjustments. Great work in this video. We learned a lot about working with parameters in a function. This understanding is something you'll need as you continue to write Python scripts. We previously learned how we can pass arguments into a function. We can do more than pass information into a function. We can also send information out of one. Return statements allow us to do this. A return statement is a Python statement that executes inside a function and sends information back to the function call. This ability to send information back from a function is useful to a security analyst in various ways. As one example, an analyst might have a function that checks whether someone is allowed to access a particular file and will return a Boolean value of true or false to the larger program. We'll explore another example. Let's create a function related to analyzing login attempts. Based on the information it takes in, this function will compute the percentage of failed attempts and return this percentage. The program could use this information in a variety of ways. For example, it might be used to determine whether or not to lock an account. So let's get started and learn how to return information from a function. Just like before, we start by defining our function. We'll name it calculateFails. And we'll set two parameters related to login attempts. One for total attempts and one for failed attempts. Next, we'll tell Python what we want this function to do. We want this function to store the percentage of failed attempts in a variable called fail percentage. We need to divide failed attempts by total attempts to get this percentage. So far, this is similar to what we learned previously. But now, let's learn how to return the fail percentage. To do this, we need to use the keyword return. Return is used to return information from a function. In our case, we'll return the percentage we just calculated. So after the keyword return, we'll type fail percentage. This is our variable that contains this information. Now, we're ready to call this function. We'll calculate the percentage for a user who has logged in 4 times with 2 failed attempts. So our arguments are 4 and 2. When we run this, the function returns the percentage of failed attempts. It's 0.5 or 50%, but in some Python environments, this might not be printed to the screen. We cannot use the specific variable named fail percentage outside of the function. So, in order to use this information in another part of the program, we would need to return the value from the function and assign it to a new variable. Let's check this out. This time, when the function is called, the value that's returned is stored in a variable called percentage. Then, we can use this variable in additional code. For example, we can write a conditional that checks if the percentage of failed attempts is greater than or equal to 50%. When this condition is met, we can tell Python to print an account locked message. Let's run this code. And this time, the percentage isn't returned to the screen. Instead, we get the account locked message. Coming up, we'll discuss more functions, but this time, we'll go over a few that are ready for use and built into Python. Now that we know how to create our own functions, let's also explore a few of Python's built-in functions. As we discussed previously, built-in functions are functions that exist within Python and can be called directly. Our only job is to call them by their name, and we already described a few throughout the course. For example, Python's print and type functions. Let's quickly review those 2 built-in functions before learning about new ones. First, print outputs a specified object to the screen, and then the type function returns the data type of its input. Previously, we've been using functions independently from one another. For example, we ask Python to print something, or we ask Python to return the data type of something. As we begin to explore built-in functions, we'll often need to use multiple functions together. We can do this by passing one function into another as an argument. For example, in this line of code, Python first returns the data type of hello as a string. Then, this return value is passed into the print function. This means the data type of a string will be printed to the screen. Print and type are not the only functions you'll see used together in this way. In all cases, the general syntax is the same. The inner function is processed first, and then its return value is passed to the outer function. Let's consider another aspect of working with built-in functions. When working with functions, you have to understand what their expected inputs and outputs are. Some functions only expect specific data types and will return a type error if you use the wrong one. Other functions need a specific amount of parameters or return a different data type. The print function, for example, can take in any data type as its input. It can also take in any number of parameters, even ones with different data types. Let's explore the input and output of the print function. We'll enter 3 arguments. The first contains string data. Then, a comma is used to separate this from the second argument. This second argument is an integer. Finally, after another comma, our third argument is another string. Now, let's run this code. Perfect. This printed out just as expected. The type function also takes in all data types, but it only accepts one parameter. Let's explore this input and output too. Our first line of code will first determine the data type of the word security, and then pass what it returns into a print function. And the second line of code will do the same thing with the value of 73.2. Now, let's run this and see what happens. Python first returns output that tells us that the word security is string data. Next, it returns another line of output that tells us that 73.2 is float data. Now, we know what to consider before using a built-in function. We have to know exactly how many parameters it requires and what data types they can be. We also need to know what kind of output it produces. Let's learn a couple of new built-in functions and think about this. We'll start with max. The max function returns the largest numeric input passed into it. It doesn't have a defined number of parameters that it accepts. Let's explore the max function. We'll pass 3 arguments into max in the form of variables. So let's first define those variables. We'll set the value of a to 3, b to 9, and c to 6. Then we'll pass these variables into the max function and print them. Let's run this. It tells us the highest value among those is 9. Now, let's study one more built-in function, the sorted function. The sorted function sorts the components of a list. This function can be very useful in a security setting. When working with lists, we often have to sort them. With lists of numbers, we sort them from smallest to largest, or the other way around. With lists of string data, we might need to sort them alphabetically. Imagine you have a list that contains usernames in your organization, and you wanted to sort them alphabetically. Let's use Python's sorted function for this. We'll specify our list through a variable named usernames. In this list, we'll include all of the usernames we want to sort. Now, we'll use the sorted function to sort these names by passing the usernames variable into it. And then we'll pass its output into the printed statement, so it can be displayed on the screen. And when we run it, everything is now in order. These are just a few of the built-in functions available for your use. As you work more in Python, you'll become familiar with others that can help you in your programs. Hello again. Previously, we learned about built-in functions in Python. Built-in functions come standard with every version of Python and consist of functions such as print, type, max, and many more. To access additional pre-built functions, you can import a library. A library is a collection of modules that provide code users can access in their programs. All libraries are generally made up of several modules. A module is a Python file that contains additional functions, variables, classes, and any kind of runnable code. Think of them as safe Python files that contain useful functionality. Modules may be made up of small and simple lines of code, or could be complex and lengthy in size. Either way, they help save programmers' time and make code more readable. Now, let's focus specifically on the Python standard library. The Python standard library is an extensive collection of usable Python code that often comes packaged with Python. One example of a module from the Python standard library is the RE module. This is a useful module for a security analyst when they are tasked with searching for patterns in log files. Another module is the CSV module. It allows you to work efficiently with CSV files. The Python standard library also contains glob and OS modules for interacting with the command line, as well as time and date time for working with timestamps. These are just a few of the modules in Python standard library. In addition to what's always available through the Python standard library, you can also download external libraries. A couple of examples are Beautiful Soup for parsing HTML website files and NumPy for arrays and mathematical computations. These libraries will assist you as a security analyst in network traffic analysis, log file parsing, and complex math. Overall, Python libraries and modules are useful because they provide pre-programmed functions and variables. This saves time for the user. I encourage you to explore some of the libraries and modules we discuss here and the ways they might be helpful to you as you work in Python. Welcome back. One of the advantages to programming in Python is that it's a very readable language. It also helps that the Python community shares a set of guidelines that promote clean and neat code. These are called style guides. A style guide is a manual that informs the writing, formatting, and design of documents. As it relates to programming, the style guides are intended to help programmers follow similar conventions. The PEP8 Style Guide is a resource that provides stylistic guidelines for programmers working in Python. PEP is short for Python Enhancement Proposals. PEP8 provides programmers with suggestions related to syntax. They're not mandatory, but they help create consistency among programmers to make sure that others can easily understand our code. It's essentially based on the principle that code is read much more often than it's written. This is a great resource for anyone who wants to learn how to style and format their Python code in a manner consistent with other programmers. For example, PEP8 discusses comments. A comment is a note programmers make about the intentions behind their code. They are inserted in computer programs to indicate what the code is doing and why. PEP8 gives specific recommendations like making your comments clear and keeping them up to date when the code changes. Here's an example of code without a comment. The person who wrote it might know what's going on, but what about others who need to read it? They might not understand the context behind the failed attempts variable and why it prints account locked if it's greater than 5. And the original writer might need to revisit this code in the future, for example, to debug the larger program. Without the comment, they would also be less efficient. But in this example, we've added a comment. Other readers can quickly understand what our program and its variables are doing. Comments should be short and right to the point. Next, let's talk about another important aspect of code readability: indentation. Indentation is a space added at the beginning of a line of code. This both improves readability and ensures that code is executed properly. There are instances when you must indent lines of code to establish connections with other lines of code. This groups the indented lines of code together and establishes a connection with a previous line of code that isn't indented. The body of a conditional statement is one example of this. We need to make sure this printf statement executes only when the condition is met. Indenting here provides this instruction to Python. If the printf statement were not indented, Python would execute this printf statement outside of the conditional, and it would always print. This would be problematic because you would get a message that updates are needed, even if they're not. To indent, you must add at least one space before a line of code. Typically, programmers add 2 to 4 spaces for visual clarity. The PEP8 Style Guide recommends 4 spaces. At my first engineering job, I wrote a script to help validate and launch firewall rules. Initially, my script worked well, but it became hard to read a year later when we were trying to expand its functionality. My programming knowledge and coding style had evolved over that year, as had the coding practices of my teammates. Our organization did not use a coding style guide at that time, so our codes were very different, hard to read, and did not scale well. This caused a lot of challenges and required additional work to fix. Ensuring that code is readable and can be modified over time, it's why it's important for security professionals to adhere to coding style guides, and why style guides are so important for organizations to utilize. The ability to write readable code is key when working in Python. As we head into the next part of our course, we'll continue to develop effective code practices for better readability. Great work on making it this far in the Python course. You put in a lot of work and effort towards learning more about how you can use Python effectively and efficiently. Let's quickly recap the concepts you learned throughout the videos. First, we started by understanding the role of functions in Python. They can save you a lot of time. You learn how to incorporate built-in functions and how to develop your own functions to meet your needs. We then shifted our focus towards modules and libraries, which gave us access to a lot more functions than those built into Python. Lastly, we moved to learning about code readability and best practices to write clean, understandable code. With these understandings, you're ready to learn how powerful Python can really be for task automation, and how it can help you going forward as a security analyst. Thank you for taking the time to go through this course with me. I'll meet you in the next videos. As a security analyst, you'll work with a lot of data. Being able to develop solutions for managing this data is very important. What we're about to learn in Python will help you with that. Previously, we set foundations for what we're going to do in this section. We learned all about data types and variables. We also covered conditional and iterative statements. We learned about built-in functions and even created our own functions. Here, we'll build on that in a few different ways. First, you'll learn more about working with strings and lists. We'll expand the ways that you can work with these data types, including extracting characters from strings or items from lists. Our next focus is on writing algorithms. You'll consider a set of rules that can be applied in Python to solve a security-related problem. And finally, we'll further expand the ways we can search for strings when we explore using regular expressions. We're going to have a lot of fun, and you'll start writing some really interesting code in Python. I can't wait to get started. Knowing how to work with string data in security is important. For example, you might find yourself working with usernames to find patterns in login information. We're going to revisit the string data type and learn how to work with it in Python. First, let's have a quick refresher on strings. We defined string data as data consisting of an ordered sequence of characters. In Python, strings are written in between quotation marks. It's okay to use either double or single quotation marks, but in this course, we've been using double quotation marks. As examples, we have the strings hello, 1, 2, 3, and number 1. We also previously covered variables. Here, the variable myString is currently storing the string security. You can also create a string from another data type, such as an integer or a float. To do that, we need to introduce a new built-in function, the string function. The string function is a function that converts the input object into a string. Converting objects to strings allows us to perform tasks that are only possible for strings. For example, we might convert an integer into a string to remove elements from it, or to reorder it. Both are difficult for an integer data type. Let's practice converting an integer to a string. We'll apply the string function to the integer 123. Now, the variable newString contains a string of 3 characters, 1, 2, and 3. Let's print its type to check. We'll run it. Perfect. It tells us that we now have a string. Awesome. So far, we know different ways to create and store a string. Now, let's explore how to perform some basic string operations. Our first example is the length function. The length function is a function that returns the number of elements in an object. Using it on a string tells us how many characters the string has. Earlier in the program, we learned that IP addresses have 2 versions, IPv4 or IPv6. IPv4 addresses have a maximum of 15 characters. So, a security professional might use the length function to check if an IPv4 address is valid. If its length is greater than 15 characters, then we'd know that it's an invalid IPv4 address. Let's use this function to print the length of the string hello. We'll nest the length function within the print function because we want to first calculate the length of this string and then print it to the screen. Okay, let's run this and check out how many characters Python counts. The output is 5, 1 for each letter in the word hello. We can also use the addition operator on strings. This is called string concatenation. The string concatenation is the process of joining 2 strings together. For example, we can add the strings hello and word together. To concatenate strings, we can use the plus symbol. After we run it, we get hello world, with no spaces in between the 2 strings. It's important to note that some operators don't work for strings. For example, you cannot use a minus sign to subtract the 2 strings. Finally, we're going to talk about string methods. A method is a function that belongs to a specific data type. So, using string methods on another data type, like an integer, would cause an error. Unlike other functions, methods appear after the string. 2 common string methods are the upper and the lower methods. The upper method returns a copy of the string in all uppercase letters. Let's apply the upper method to the string hello. We'll place this inside of a print function to output it to the screen. Let's focus on the unique syntax of methods. After our string hello, we place a period or dot, and then specify the method we want to use. Here, that's upper. Okay, now we're ready to run this. Hello is printed to the screen in all uppercase letters. Similarly, the lower method returns a copy of the string in all lowercase letters. Let's apply the lower method on the hello string. Remember that we need to put the string and the method inside of a print function to output the results. And now we have the string printed in all lowercase letters. Coming up, we're going to learn a lot more about strings, like indexing and splitting strings. I'm looking forward to meeting you there. In security, there are a variety of reasons we might need to search through a string. For example, we might need to locate a username in a security log. Or if we learn that a certain IP address is associated with malware, we might search for this address in a network log. And the first step in being able to use Python in these ways is learning about the index of characters in a string. The index is a number assigned to every element in a sequence that indicates its position. In this video, we are discussing strings. So, the index is the position of each character in a string. Let's start with the string hello. Every character in the string is assigned an index. In Python, we start counting indices from 0. So, the character H has an index of 0, and E has an index of 1, and so on. Let's take this into Python and practice using indices. Placing an index in square brackets after a string returns the character at that index. Let's place the index 1 in square brackets after hello and run it. This returns the character E. Remember, indices start at 0, so an index of 1 isn't the first character in the word. But what if we wanted to return more than just one character? We can extract a larger part of a string by specifying a set of indices, and this is called a slice. When taking a slice from a string, we specify where the slice starts and where the slice ends, so we provide two indices. The first index is the beginning, which is included in the output. The second index is the end, but it's not included in the final output. Instead, Python stops the slice at the element before the second index. For example, if we wanted to take the letters E, L, L from hello, we would start the interval from the index 1, but we'd end before the index 4. Let's try this example and extract a slice from a string in Python. Let's type in the string and take the slice starting at index 1 and ending before index 4. Now, let's run the code and examine the output. And there's the slice we wanted. Now that we know how to describe the location of a character in a string, let's learn how to search in a string. To do this, we need to use the index method. The index method finds the first occurrence of the input in a string and returns its location. Let's practice using the index method in Python. Let's say we want to use the index method to find the character E in the string hello. We'll locate the first instance of the character E. Let's examine this line in more detail. After writing the string and the index method, we use the character we want to find as the argument of the index method. Remember, strings in Python are case sensitive, so we need to make sure we use the appropriate case with the index method. Let's run this code now. This returns the number 1. This is because E has an index value of 1. Now, let's explore an example where a character repeats multiple times in the string. Let's try searching for the character L. We start with similar code as before, passing the argument L instead of E to the index method. Now, let's run this code and investigate the result. The result is the index 2. This tells us that the method only identified the first occurrence of the character L, and not the second. This is an important detail to notice when working with the index method. As a security analyst, learning how to work with indices allows you to find certain parts in a string. For example, if you need to find the location of the @ symbol in an email, you can use the index method to find what you're looking for with one line of code. Now, let's turn our attention to an important property of strings. Have you ever heard the expression, "some things never change"? It might be said about the comfortable feeling you have with a good friend, even when you haven't seen them for a long time. Well, in Python, we can also say this about strings. Strings are immutable. In Python, immutable means that it cannot be changed after it's created and assigned a value. Let's break this down with an example. Let's assign the string hello to the variable myString. Now, if we want to change the character E to an A, so myString has the value HALLO, then we might be inclined to use index notation. But here we get an error. MyString is immutable, so we cannot make changes like this. And there you have it. You just learned how to index and slice into strings. You've also seen that strings are immutable, so you cannot reassign characters after a string has been defined. Coming up, we'll learn about list operations and see that lists can be changed with index notation. Meet you there. Another data type we discussed previously is the list. Lists are useful because they allow you to store multiple pieces of data in a single variable. In the security profession, you will work with a variety of lists. For example, you may have a list of IP addresses that have accessed a network, and another list might hold information on applications that are blocked from running on the system. Let's recap how to create a list in Python. In this case, the items in our list are the letters A through E. We separate them by commas and surround them with square brackets. We can also assign our list to a variable to make it easier to use later. Here, we've named our variable myList. When we access specific elements from lists, we use syntax similar to when we access specific elements from strings. We place its index value in brackets after the variable that stores the list. So this would access the second item in the list. This is because in Python, we start counting the elements in a list at 0 and not at 1. So the index for the first element is 0, and the index for the second element is 1. Let's try extracting some elements from a list. We'll extract the second element by putting 1 in brackets after the variable. We place this in a print function to output the results. And after we run it, Python outputs the letter B. Similar to strings, we can also concatenate lists with the plus sign. List concatenation is combining two lists into one by placing the elements of the second list directly after the elements of the first list. Let's work with this in Python. Let's concatenate two lists. First, we define the same list as in the previous example and store it in the variable myList. Now, let's define an additional list with the numbers 1 through 4. Finally, let's concatenate the two lists with a plus sign and print out the result. And when we run it, we have a final concatenated list. Having discussed the similarities, let's now explore the differences between lists and strings. We mentioned earlier that strings are immutable, meaning after they are defined, they cannot be changed. Lists, on the other hand, do not have this property, and we can freely change, add, and remove list values. So, for example, if we have a list of malicious IP addresses, then every time a new malicious IP address is identified, we can easily add it to the list. Let's first try changing a specific element in a list in Python. We start with the list used in the previous example. To change an element in a list, we combine what we learned about bracket notation with what we learned about variable assignment. Let's change the second element in my list, which is the string b, to the number 7. We place the object we want to change on the left-hand side of the variable assignment. In this case, we'll change the second element in my list. Then, we place an equal sign to indicate we are reassigning this element of the list. Finally, we place the object to take its place on the right-hand side. Here, we'll reassign the second list element to a value of 7. Now, let's print out the list and run the code to examine the change. Perfect. The letter B is now changed to the number 7. Now, let's take a look at methods for inserting and removing elements in lists. The first method we'll work with in this video is the insert method. The insert method adds an element in a specific position inside a list. The method takes 2 arguments. The first is the position we're adding the element to, and the second is the element we want to add. Let's use the insert method. We'll start with the list we defined in our myList variable. Then we type mylist.insert and pass in 2 arguments. The first argument is the position where we want to insert the new information. In this case, we want to insert into index 1. The second argument is the information we want to add to the list. In this case, the integer 7. Now, let's print my list. Our list still begins with A, the element with an index of 0. And now we have the integer 7 in the next position. The position represented with an index of 1. Notice that the letter B, which was originally at index 1, did not get replaced like when we use bracket notation. With the insert method, every element beyond index 1 is simply shifted down by 1 position. The index of B is now 2. Sometimes, we might want to remove an element that is no longer needed from a list. To do this, we can use the remove method. The remove method removes the first occurrence of a specific element in a list. Unlike insert, the argument of remove is not an index value. Instead, you directly type the element you want to remove. The remove method removes the first instance of it in the list. Let's use the remove method to delete the letter D from our list. We'll type the name of our variable, myList, then add the remove method. We want to remove D from this list, so we'll place it in quotation marks as our argument. Then we'll print myList. And let's run this. Perfect. D has now been removed from the list. Just like with strings, being able to search through lists is a necessary skill for security analysts. I'm looking forward to expanding our understanding as we move forward in this course. In our everyday lives, we frequently follow rules for solving problems. As a simple example, imagine you want a cup of coffee. If you've made coffee many times, then you likely follow a process to make it. First, you grab your favorite mug. Then, you pour water into the coffee maker and add your coffee grounds. You press the start button and wait a few minutes. Finally, you enjoy your fresh cup of coffee. Even if you have a different approach to making coffee or don't drink coffee at all, you likely follow a set of rules for completing similar everyday tasks. When you complete these routine tasks, you're following an algorithm. An algorithm is a set of rules that solve a problem. In more detail, an algorithm is a set of steps that take an input from a problem, uses this input to perform tasks, and returns a solution as an output. Let's explore how algorithms can be used to solve problems in Python. Imagine that you, as a security analyst, have a list of IP addresses. You want to extract the first 3 digits of each IP address, which will tell you information about the networks that these IP addresses belong to. To do this, we're going to write an algorithm that involves multiple Python concepts that we've covered so far: loops, lists, and strings. Here's a list with IP addresses that are stored as strings. For privacy reasons, in our example, we are not showing the full IP addresses. Our goal is to extract the first 3 numbers of each address and store them in a new list. Before we write any Python code, let's break down an approach to solving this problem with an algorithm. What if you had one IP address instead of an entire list? Well, then the problem becomes much simpler. The first step in solving the problem will be to use string slicing to extract the first 3 digits from one IP address. Now, let's consider how to apply this to an entire list. As the second step, we'll use a loop to apply that solution to every IP address on the list. Previously, you learned about string slicing, so let's write some Python code to solve the problem for one IP address. Here, we are starting with one IP address that begins with 198.567. And we'll write a few lines of code to extract the first 3 characters. We'll use the bracket notation to slice the string. Inside the print statement, we have the address variable, which contains the IP address we want to slice. Remember that Python starts counting at 0, so to get the first 3 characters, we start our slice at index 0. And then continue all the way until index 3. Remember that Python excludes the final index. In other words, Python will return the characters at index 0, 1, and 2. Now, let's run this. We get the first 3 digits of the address, 198. Now that we're able to solve this problem for one IP address, we can put this code into a loop and apply it to all IP addresses in the original list. Before we do this, let's introduce one more method that we'll be using in this code: the append method. The append method adds input to the end of a list. For example, let's say that my list contains 1, 2, and 3. With this code, we can use the append method to add 4 to this list. First, we're given the IP list. Now, we're ready to extract the first 3 characters from each element in this list. Let's create an empty list to store the first 3 characters of each IP from the list. Now, we can start the for loop. Let's break this down. The word for tells Python that we are about to start a for loop. We then choose address as the variable inside of the for loop, and we specify the list called IP as the iterable. As the loop runs, each element from the IP list will be stored temporarily in the address variable. Inside the for loop, we have a line of code to add the slice from address to the networks list. Breaking this down, we use the code we wrote earlier to get the first 3 characters of an IP address. We'll use our append method to add an item to the end of a list. In this case, we're adding to the networks list. Finally, let's print the networks list and run the code. The variable networks now contains a list of the first 3 digits of each IP address in the original list, IP. That was a lot of information. Designing algorithms can be challenging, so it's a good idea to break them down into smaller problems before jumping into writing your code. We'll continue to practice this idea in the upcoming videos. Meet you there. We've already learned a lot about working with strings. This includes working with their positional indices and slicing them. In the previous video, we applied this to extract the first 3 digits from a list of IP addresses. In this video, we're going to focus on a more advanced way to search through strings. We'll learn about searching for patterns in strings through regular expressions. A regular expression, shortened to regex, is a sequence of characters that forms a pattern. This pattern can be used when searching within log files. We can use them to search for any kind of pattern. For example, we can find all strings that start with a certain prefix, or we can find all strings that are a certain length. We can apply this to a security context in a variety of ways. For example, let's say we needed to find all IP addresses with a network ID of 184. Regular expressions would allow us to efficiently search for this pattern. We'll examine another example throughout this video. Let's say that we want to extract all the email addresses contained in a log. If we try to do this through the index method, we would need the exact email addresses we were searching for. As security analysts, we rarely have that kind of information. But if we use a regular expression that tells Python how an email address is structured, it would return all the strings that have the same elements as an email address. Even if we were given a log file with thousands of lines and entries, we could extract every email in the file by searching for the structure of an email address through a regular expression. We wouldn't need to know the specific emails to extract them. Let's explore the regular expression symbols that we need to do this. To begin, let's learn about the plus sign. The plus sign is a regular expression symbol that represents one or more occurrences of a specific character. Let's explain that through an example pattern. The regular expression pattern a plus sign matches a string of any length in which a is repeated. For example, just a single a, 3 a's in a row, or 5 a's in a row. It could even be 1,000 a's in a row. We can start working with a quick example to see which strings this pattern would extract. Let's start with this string of device IDs. These are all the instances of the letter A, written once or multiple times in a row. The first instance has 1A. The second has 2A's. The third one has 1A, and the fourth has 3A's. So if we told Python to find matches to the A plus sign regular expression, it would return this list of A's. The other building block we need is the \W symbol. This matches with any alphanumeric character, but it doesn't match symbols. 1, K, and I are just 3 examples of what \W matches. Regular expressions can easily be combined to allow for even more patterns in a search. Before we apply this to our email context, let's explore the patterns we can search for if we combine the \W with the plus sign. \W matches any alphanumeric character, and the plus sign matches any number of occurrences of the character before it. This means that the combination of \W plus sign matches an alphanumeric string of any length. The \W provides flexibility in the alphanumeric characters that this regular expression matches. And the plus sign provides flexibility in the length of the string that it matches. The strings 192, ABC123, and security are just 3 possible strings that match to \W plus sign. Now, let's apply this to extracting email addresses from a log. Email addresses consist of text separated by certain symbols, like the @ symbol and the period. Let's learn how we can represent this as a regular expression. To start, let's think about the format of a typical email address. For example, user1@email1.com. The first segment of an email address contains alphanumeric characters, and the number of alphanumeric characters may vary in length. We can use our regular expression \W plus sign for this portion to match to an alphanumeric string of any length. The next segment in an email address is the @ symbol. This segment is always present. We'll enter this directly in our regular expression. Including this is essential for ensuring that Python distinguishes email addresses from other strings. After the @ symbol is the domain name. Just like the first segment, this one varies depending on the email address, but it always contains alphanumeric characters. So we can use \w+, again to allow for this variation. Next, just like the @ symbol, a period is always part of an email address. But unlike the @ symbol, in regular expressions, the period has a special meaning. For this reason, we need to use \period here. When we add a backslash in front of it, we let Python know that we are not intending to use it as an operator, and that our pattern should include a period in this location. For the last segment, we can also use \w+. This final part of an email address is often com, but might be other strings like net. When we put the pieces together, we get the regular expression we'll use to find email addresses in our log. This pattern will match all email addresses. It would exclude everything else in our string. This is because we've included the @ symbol and the period where they appear in the structure of an email address. Let's bring this into Python. We'll use regular expressions to extract email addresses from a string. Regular expressions can be used when the RE module is imported into Python. So we begin with that step. Later, we'll learn how to import and open files like logs. But for now, we've stored our log as a string variable named email log. Because this is a multi-line string, we're using 3 sets of quotation marks instead of just 1. Next, we'll apply the findAll function from the RE module to our regular expression. re.findAll returns a list of matches to our regular expression. Let's use this with the regular expression we created earlier for email addresses. The first argument is the pattern that we want to match. Notice that we place it in quotation marks. The second argument indicates where to search for the pattern. In this case, we're searching through the string contained within the email log variable. When we run this, we get a list of all the emails in the string. Imagine applying this to a log with thousands of entries. Pretty useful, right? This was just an introduction to the power of regular expressions. There are many more symbols you can use. I encourage you to explore regular expressions on your own and learn more. Congratulations! We accomplished a lot together. Let's take time to quickly go through all the new concepts we covered. We started this course by focusing on working with strings and lists. We learned methods that work specifically with these data types. We also learned to work with indices and extract the information we need. Next, we focused on writing algorithms. We wrote a simple algorithm that sliced the network ID from a list of IP addresses. Finally, we covered using regular expressions. Regular expressions allow you to search for patterns, and this provides expanded ways to locate what you need in logs and other files. These are complex concepts, and you're always welcome to visit the videos again whenever you like. With these concepts, you took a big step towards being able to work with data and write the algorithms that security professionals need. Throughout the rest of this course, you're going to get more practice with Python and what it can offer to security analysts. We've learned a lot about Python together already, and we still have more to cover. In this section, we're going to explore how a security analyst like yourself puts Python into practice. As a security analyst, you'll likely work with security logs that capture information on various system activities. These logs are often very large and hard to quickly interpret, but Python can easily automate these tasks and make things much more efficient. So first, we'll focus on opening and reading files in Python. This includes log files. We'll then explore parsing files. This means you'll be able to work with files in ways that provide you with the security-related information that you're targeting. Finally, part of writing code is debugging code. It's important to be able to interpret error messages to make your code work. We'll cover common types of Python errors and ways to resolve them. Overall, after completing this section, you'll have a better understanding of Python and how, as a security analyst, you can use it. I can't wait to join you. Automation is a key concern in the security profession. For example, it would be difficult to monitor each individual attempt to access the system. For this reason, it's helpful to automate the security controls put in place to keep malicious actors out of the system. And it's also helpful to automate the detection of unusual activity. Python is great for automation. Let's explore 3 specific examples of this. First, imagine you're a security analyst for a healthcare company that stores confidential patient records in a database server. Your company wants to implement additional controls to protect this information. In order to enhance the security of the records, you decide to implement a timeout policy that logs out a user if they spend more than 3 minutes logging into the database. This is because it's possible that if a user is spending too much time, it could be that they are guessing the password. To do this, you can use Python to identify when a user has entered a username and start tracking the time until this user enters the correct password. Now, let's cover a different example. This time, imagine you are a security analyst working at a law firm. There have recently been some ongoing security attacks where threat actors hack into employee accounts and attempt to steal client information. They then threaten to use this maliciously. So the security team is working to target all security vulnerabilities that allow these attackers to break into the company's databases. You, personally, are responsible for tracking all user logins by checking their login timestamp, IP address, and location of login. For example, if a user logs in during the early hours of the morning, they should be flagged. Also, if they are logging in from a location that's not one of the 2 established work zones, you must flag their account. Finally, if a user is simultaneously logging from 2 different IP addresses, you must flag their account. Python can help you keep track of and analyze all of these different login information. Let's consider one final example. Imagine you are a security analyst working at a large organization. Recently, this organization has increased security measures to make sure all customer-facing applications are better protected. Since there is a password to access these applications, they want to monitor all password login attempts for suspicious activity. One sign of suspicious activity is having several failed login attempts within a short amount of time. You need to flag users if they had more than 3 login failures in the last 30 minutes. One way you could do this in Python is by parsing a static txt log file with all user login attempts to each machine. Python could structure the information in this file, including the username, IP address, timestamp, and login status. It could then use conditionals to determine if a user needs to be flagged. These are just a few examples of how a security analyst might apply Python in their day-to-day work. I hope you are as excited as I am to create solutions for security problems. Security professionals are often tasked with reviewing log files. But these files may have thousands of entries, so it can be helpful to automate this process. And that's where Python comes in. Let's start by importing a simple text file that just contains a few words and then storing it as a string in Python. All we need is the text file, its location, and the right Python keywords. We're going to start by typing a with statement. The keyword with handles errors and manages external resources. When using with, Python knows to automatically release resources that would otherwise keep our system busy until the program finishes running. It's often used in file handling to automatically close a file after reading it. To open files and then read them, we write a statement that begins with the keyword with. Then we use the open function. Open is a function that opens a file in Python. The first parameter is the name of the text file on your computer or a link to it on the internet. Depending on the Python environment, you might also need to include a path to this file. Remember to include the .txt extension in the file name. Now, let's discuss the second parameter. This parameter in the open function tells Python what we want to do with the file. In our case, we want to read a file, so we use the letter R between quotation marks. If we wanted to write to a file, we would replace this R with a W, but here we're focusing on reading. Finally, file is a variable that contains the file information as long as we're inside the with statement. Like with other types of statements, we end our with statement with a colon. The code that comes after the colon will tell Python what to do with the content of the file. Let's go into Python and use what we learned. We're ready to open a text file in Python. Now, we'll type our with statement. Next, we'll use Python's built-in read method. The read method converts files into strings. Now, let's go back to our with statement. Similar to a for loop, with statements start an indent on the next line. This tells Python that this code is happening inside the with statement. Inside of the statement, we're going to use the read function to turn our file into a string and store that inside a new variable. This new variable can be used outside of the with statement. So let's exit the with statement by removing the indentation and print the variable. Perfect. The string from the text prints out. Coming up, we're going to discuss parsing files, so we are equipped to handle security logs in the future. Now that you know how to import text files into Python, we're going to take this one step further and learn how to give them a structure. This will allow us to analyze them more easily. This process is often referred to as parsing. Parsing is the process of converting data into a more readable format. To do this, we're going to put together everything we learn about lists and strings and learn another method for working with strings in Python. The method we need is the split method. The split method converts a string into a list. It does this by separating the string based on a specified character, or if no argument is passed, every time it encounters a white space, it separates the string. So a split would convert the string we are learning about parsing into this list. We are using the split method to separate the strings into smaller chunks that we can analyze more easily than one big block of text. In this video, we'll work with an example of a security log where every line represents a new data point. Store these points in a list. We want to separate the text based on the new line. Python considers a new line to be a type of white space. So we can use the split method without passing an argument. We'll start with our code from the previous video. Remember, we used this code to open a file and then read it into a string. Now, let's split that string into a list using the split method and then print the output. After we run it, Python outputs a list of usernames instead of one big string of them. If we want to save this list, we would need to assign it to another variable. For example, we can call the variable usernames, and then we run it again. And now this list can be reused in other code. Congratulations! You just learned the basics of parsing a text file in Python. In the next videos, we're going to be exploring techniques that help us work more in depth with data in Python. We're now going to bring all of the pieces together to import a file, parse it, and implement a simple algorithm to help us detect suspicious login attempts. In this video, we want to create a program that runs every time a new user logs in and checks if that user has had 3 or more failed login attempts. First, let's discuss the structure of our inputs to build a strategy to develop our program. We have a log file stored in a txt format that contains one username per line. Each username represents a failed login attempt. So when a user logs in, we want our program to check for their username and count how many times that username is in our log file. If that username is repeated 3 or more times, the program returns an alert. We'll start with code that imports the file of login attempts, splits it, and it stores it into a variable named usernames. Let's try printing the variable usernames to check for its contents. We'll run this. Perfect. This is exactly what we expected. The variable usernames is ready to be used in our algorithm. Now, let's develop a strategy for counting username occurrences in a list. We'll start with the first 8 elements of the usernames list. We notice that there are 2 occurrences of the username ERAAB in the list. But how would we tell Python to count this? We'll implement a for loop that iterates through every element. Let's represent the loop variable with an arrow. We also define a counter variable that starts at 0. So our for loop starts at the username ELARSON. At every element, Python asks, is this element equal to the string ERAAB? If the answer is yes, the counter goes up by 1. If it isn't, then the counter stays the same. Since ELARSON is not the same as ERAAB, the counter remains 0. Then we move on to the next element. We encounter our first occurrence of ERAAB. At this point, the counter increases by 1. As we move to the next element, we find another occurrence of ERAAB. So we increase our counter by 1 again. That means that our counter is now at 2. We will continue this process for the rest of the list. Now that we know the solution, let's talk about how to implement it in Python. Solving the problem in Python will involve a for loop, a counter variable, and an if statement. Let's get back into our code. We'll create a function that counts a user's failed login attempts. First, let's define our function. We'll call it login check. It takes 2 parameters. The first is called login list. These will be used for the list of failed login attempts. The second is called current user. These will be used for the user who logs in. Inside of this function, we start by defining the counter variable and set its value to 0. Now, we start the for loop. We'll use I as our loop variable and iterate through the login list. In other words, as the loop iterates, it would run through all the failed login attempts in the list. Directly inside of the for loop, we start the if statement. The if statement checks if our loop variable is equal to the current user we're searching for. If this condition is true, we want to add 1 to the counter. We're almost done with our algorithm. Now, we just need the final if-else statement to print the alert. If the counter adds up to 3 or more, we need to tell the user that their account is locked, so they can't log in. We'll also type an else statement for users who can log in. Our algorithm is complete. Let's try out our new function on an example username. We can pull out a few of the usernames in the list and try our function on them. Let's use the first name in the list. Let's run the code. According to our code, this user can log in. They have fewer than 3 failed login attempts. Now, let's go back to our user ERAAB. Remember, they had 2 entries in the list of the first 8 names in our failed login attempts. Do you think they'll be able to log in? When we run, we get an account locked message. This means they had 3 or more failed login attempts. Excellent work. You just developed your first security algorithm involving a log. As you grow in your skills, you learn how to make this algorithm more efficient. But this solution works well for now. In this video, we recapped everything we learned so far, from list operations to algorithm development, all the way to file parsing. We did this while building an algorithm we can apply in a security context. As a security analyst, you might be required to read or write code. And one of the biggest challenges is getting it to run and function properly. In fact, fixing complex errors in code can sometimes take up just as much, if not more time, than writing your code. This is why it's important to develop this skill. Now that you learned the basics of coding in Python, it's important to learn how to deal with errors. For that reason, we'll focus on debugging your code. Debugging is the practice of identifying and fixing errors in code. In this video, we'll explore some techniques for this. There are 3 types of errors: syntax errors, logic errors, and exceptions. Syntax errors involve invalid usage of the Python language, such as forgetting to add a colon after a function header. Let's explore this type of error. When we run this code, we get a message that indicates there's a syntax error. Depending on the Python environment, it might also display additional details. We'll typically get information about the error, like its location. These syntax errors are often easy to fix since you can find exactly where the error happened. They are similar to correcting simple grammar mistakes in an email. Since the error message tells us the problem is on the line that defines the function, let's go there. In this case, we can add a colon to the header and resolve our error. When we run it again, there's no longer an error message. This is just one example of a syntax error. Other examples include omitting a parenthesis after a function, misspelling a Python keyword, or not properly closing quotation marks for a string. Next, let's focus on logic errors. Logic errors may not cause error messages. Instead, they produce unintended results. A logic error could be as simple as writing the incorrect text within a print statement, or it might involve something like writing a less than symbol instead of less than or equal to symbol. This changing operator would exclude a value that was needed for the code to work as intended. For example, imagine that you reach out to a response team when the priority level of an issue is less than 3 instead of less than or equal to 3. This means all events classified as priority level 3 could go unnoticed and unresolved. To diagnose a logic error that's difficult to find, one strategy is to use print statements. You'll need to insert print statements throughout your code. The print statements should describe the location in the code. For example, print line 20 or print line 55 inside the conditional. The idea is to use these print statements to identify which sections of the code are functioning properly. When a print statement doesn't print as expected, this helps you identify sections of the code with problems. Another option for identifying logic errors is to use a debugger. A debugger will let you insert breakpoints into your code. Breakpoints allow you to segment your code into sections and run just one portion at a time. Just like with the print statements, running these sections independently can help isolate problems in the code. Okay, let's move on to our last type of error, an exception. Exceptions happen when the program doesn't know how to execute code, even though there are no problems with the syntax. Exceptions occur for a variety of reasons. For example, they can happen when something is mathematically impossible, like asking the code to divide something by 0. Exceptions might also happen when you ask Python to access index values that don't exist, or when Python doesn't recognize variable or function names. Exceptions also may occur when you use an incorrect data type. Let's demonstrate an exception. Let's say you have a variable called myString that contains the word security. Since this string has 8 characters, we can successfully print any index less than 8. Index 0 contains S. Index 1 contains E. And index 2 contains C. But if you try to access the character at index 100, you'll get an error. Let's run this and explore what happens. After it successfully prints the first 3 statements, we get an error message. String index out of range. For exception errors, you can also make use of debuggers and print statements to figure out the potential source of error. Errors and exceptions can be expected when working in Python. The important thing is to know how to deal with them. Hopefully, this video provided some valuable insight about debugging code. This will help ensure that the code that you write is functional. Let's say our coworkers need some help getting their code to work, and we offer to debug their code to make sure it runs smoothly. First, we need to know about the purpose of the code. In this case, the purpose of the code is to parse a single line from a log file and return it. The log file we're using tracks potential issues with software applications. Each line in the log contains the HTTP response status codes, the date, the time, and the application name. When writing this code, our coworkers consider whether all the status codes needed to be parsed. Since 200 signals a successful event, they concluded that lines with this status code shouldn't be parsed. Instead, Python should return a message indicating that parsing wasn't needed. To start the debugging process, let's first run the code to identify what errors appear. Our first error is a syntax error. The error message also tells us the syntax error occurs in a line that defines a function. So let's scroll to that part of the code. As you might recall, these function headers should end with a colon. Let's go ahead and add that to the code. Now the syntax error should go away. So let's run the code again. So now our syntax error is gone, which is good news. But we have another error, a name error. Name error is actually a type of exception, meaning we've written valid syntax, but Python can't process the statement. According to the error, the interpreter doesn't understand the variable application name at the point where it's being added to the parse line list. Let's examine that section of code. This error means we haven't assigned the variable name properly. So now, let's go back to where it was first assigned and determine what happened. We find that this variable is misspelled. There should be 2 P's in application name, not 1. Let's correct the spelling. Now that we fix it, it should work. So let's run the code. Great. We fixed an error and an exception. And we no longer have any error messages. But this doesn't mean our debugging work is done. Let's make sure the logic of the program works as intended by examining the output. Our output is a parse line. In most cases, this would be what we wanted. But as you might recall, if the status code is 200, our code shouldn't parse the line. Instead, it should print a message that no parsing is needed. And when we call it with a status code of 200, there was a logic error because this message wasn't displayed. So let's go back to the conditional we used to handle a status code of 200 and investigate. To find the source of the issue, let's add print statements. In our print statements, we'll include the line number and a description of the location. We'll add one print statement before the line of code containing return parsed list. We'll add another above the if statement that checks for the 200 status code to determine if it reaches the if statement. And we'll add one more print statement inside the if statement to determine whether the program even enters it. Now, let's run the code and review what gets printed. Only the first print statement printed something. The other 2 print statements after this didn't print. This means the program didn't even enter the if statement. The problem occurred somewhere before the line that returns the parse line variable. Let's investigate. When Python encounters the first return statement, which sends back the parse list, it exits the function. In other words, it returns the list before it even checks for a status code value of 200. To fix this, we must move the if statement checking for the status code somewhere before returns parse line. Let's first delete our print statements. This makes the program more efficient because it doesn't run any unneeded lines of code. Now, let's move the if statement. We'll place it right after the line of code that involves parsing the status code from the line. Let's run our code and confirm that this fixed our issue. Yes, it printed successful event, no parsing needed. Great work, we fixed this logic error. I enjoyed debugging this code with you. I hope this video strengthened your understanding of some helpful debugging strategies and gave you an idea of some errors you might encounter. Great work in this section. We focused on a few new topics that will help you put Python into practice in the security profession. First, we explored opening and reading files in Python. Security analysts work with a lot of log files, so the ability to do this is essential. Next, we covered parsing files. Log files can be very long. For this reason, structuring these files to make them more readable helps you automate your tasks and get the information you need. And last, we focus on debugging code. Knowing how to debug your code can save you a lot of time, especially as your code increases in complexity. Overall, I hope you feel proud of what you've accomplished in this section. Addressing security issues through Python is exciting, and the information we covered will allow you to do that. As we wrap up this course, I want to congratulate you for your commitment to learning Python. You should feel accomplished having explored a programming language that's useful in the security field. Let's recap some of what we've learned. First, we covered basic programming concepts in Python. We discussed variables, data types, conditional statements, and iterative statements. These topics provided important foundations for what we explored later in the course. And our next focus was on writing effective Python code. We learned how we can reuse functions in our programs to improve efficiency. We explored building functions and even created our own user-defined functions. Another topic was modules and libraries. The pre-packaged functions and variables they contain can make our work easier. Last, we learned ways to ensure our code is readable. In the next section, we focus on working with strings and lists. We learned a variety of methods that can be applied to this data type. We also learn about their indices and how to slice characters from a string or elements from a list. We put all of this together to write a simple algorithm. And then we explored how regular expressions can be used to find patterns in strings. And last, we wrap up the course with a focus on putting Python into practice. We learned how to open, read, and parse files. With these skills, you can work with the variety of logs you'll encounter in a security setting. We also learned how to debug code. This is an important skill for all programmers. Wow, you learn a lot about Python in this course. So great job. I hope soon you'll join me in using Python in the security profession. And in the meantime, I encourage you to practice and feel free to rewatch these videos whenever you like. The more you study these concepts, the easier they will become. Thanks again for joining me as we explore Python.